This is the Reactive Programming with Reactive UI webinar. And I am Jose Manuel from Brintia. You can contact me here at Twitter and LinkedIn, or using my personal email in Brabant. Currently, I'm working as a technical lead in Brintia, leading all the innovation projects. And this is it. If you have any question, just contact me. I'm very active in Twitter, and I'm usually answering and participating there. So you will have it really easy to get in touch. Well, about Brintia, if you are guessing, it's my company. We belong to a group that is composed by Brabant, Brintia itself, and EasyWork. We work in a wide range of projects and sectors, creating custom solutions for anything related to technology, from web, mobility, artificial intelligence, extended reality, and so on. Well, let's start with Reactive UI. But first, I will provide you with a little introduction to what reactive programming is. In a nutshell, reactive programming is a programming paradigm oriented around data flows and the propagation of change. Well, this means that it should be possible to express static or dynamic data flows with ease and in the programming language you choose, and that the underlying execution model will automatically propagate the changes through the data flow. It's a bit abstract what I just read, and well, it's just a definition. And in short, the reactive programming is handling the change or the changes over time, and the changes are handled by using some software artifact that is called sequences. It's the key part. The sequences can be observed, and there are two parts of this pattern: the I observer or the I observer in C#, because it has interfaces for these abstractions, and the I observable, that is, it's the sequence itself. Let's go to the key part of how we are giving this webinar, and it's because reactive programming is important. And why it's important? Well, because it addresses the problems in a different way. So they are, in fact, simpler. It looks declarative, it feels declarative, and it handles changes over time in a natural and simple way. In fact, yes, it makes complex problems simpler, way simpler, particularly those problems that are depending on time, like concurrency and buffering, or other problems that are depending on time, delays, and so on. Let's see some example of a common problem. Now, you will see. This is a list of URLs in the code. We will see it running, but first I will explain a bit more why this is a different approach and how the approach is taken. These most complex problems share some traits. They have some common features, characteristics, and in the development of our applications, most of them can be solved seeing or transforming the changes that occur in the application, converting them into data flows, or from now on, what we will call sequences. Our sequences are like pipes. I like to think about the sequences like if they are some pipe that gives an outcome. It produces something. They are emitting elements that we can transform, combine, and mix in a way similar that what we do with link U, or I don't really know what's the exact pronunciation of link U, the C sharp, this way of defining the sequence of conversions are queries, the language integrated queries that we are so used to use in C sharp. It's a bit similar. It looks like link U at first glance, but it isn't. It takes somewhat the same approach when we define things like in link U. Well, the reactive expression of the problem allows changes to be expressed naturally and in a way that is very reminiscent of functional programming, with the advantages that this entails, especially in immutability, that provides us with concurrency. The management of concurrency is very not very easy, but quite simpler. This is of enormous importance when it comes to addressing problems such as the management of data flows, or events that depend on time, as I said before. It's therefore less of a headache, or at least it isn't so much of one. Well, looking at the example, this is the usual look of our reactive sentence. The first part is the list of URLs itself. It's a list, and we can convert it to an observable using this method. And the first part is effectively doing this. We are converting the list of URLs into an observable. After converting it, we are applying the select many operator, which you might be familiar with, and it's used to project each of the returned values of the getString method, which obtains the contents. This part, the getString gets the content of the URL itself. This is the parameter that comes here, the URI. And after that, once we have created this sequence that is composed of this pipeline, we subscribe to it with the console write line method. So this means that every time a new item is pushed through the sequence that will be, in fact, this list of URLs. It will act like an observable pipe, like a pipe. The first element that will be pushed is this Amazon. You notice this is duplicated, but well, no problem. It's just an example, and it will be pushed in order through the pipe, through the observable. Selecting the getString method as a new item, so it will process all the items and will create an observable with the outcome of this method. Once we have the contents of the observable, each element will be pushed, and this subscription here will receive every element that will be pushed through the pipeline, through the observable. When I say pipeline, I'm saying the same as the sequence. They are the same concepts. But well, we will see it in action right now. I think I have tried this before, so this isn't clear. But you noticed, as soon as I execute the code, it will immediately get the contents of the URL. You are getting the HTML of every single URL. And the most interesting thing is that we are doing it concurrently. I mean, every single URL is being gotten at the same time and not waiting for the previous request to be completed. So this is very interesting because it will get the advantage of concurrency. And well, continuing with the Reactive X, the reactive programming thing. If you are not skilled with RX, with reactive extensions, the reactive way to define things, I encourage you to visit these two websites. One is the Intro to RX, and this introduction is very interesting because Intro to RX is great to get started. It's planned to be like an online book, and it's very, very interesting for newcomers, for people that is starting into the RX way of thinking. And the second one is the ReactiveX.io, and this website, it's a reference. You can see anything like an encyclopedia for the reactive programming. Let's go straight to the matter, to the subject. What's Reactive UI? Well, this way of programming, as you have imagined, has implications. One is related to the back end, and the other is for front end. And well, in the front end, we often face typical problems such as the calculation of derived properties, managing the changes that occur in the view models, or observing the changes in a rudimentary way. We tend to use events, subscriptions to these events, for example, and this is where Reactive UI is it's important. It's more fit. And this is only for the front end, but I suggest you to approach the backend problems with the reactive programming way, the reactive way, because it has a lot of benefits in addition to concurrency. It turns very complex problems into some 4, 3, 5 lines of code that is very easy to maintain and very robust. So if you are a backend developer or you feel the backend is your world, don't hesitate to take a look, because it would change your mind, and it will make a new era for you. And well, continuing with the reactive UI thing, with the framework, reactive UI facilitates the reactive approach, providing us with a series of helpers with which we can handle the changes and react to them declaratively. In the end, our view models are transformed into definitions. This is very important because reactive UI based view models are really easy to identify, because all the definitions are put into the constructor. You will see later. These definitions of the properties is they take sources and they produce the outcome. They are always faced into this particular way of thinking, like pipelines. And this is one view model, the bare view model, the naked view model. In reactive UI, this is the simplest view model you can have. And as you see, the reactive object is the base of the view model. The reactive object will be the base of our view models. Why? Well, because it has all the features we will need to be reactive with almost no boilerplate. Usually our view models will have almost all the code in their constructor, like I said before. And why? Because, well, the definitions are usually in constructor, so it's nothing. It's no surprise that they are located there. And well, definitions are that important because definitions of the properties define exactly what needs to be done instead of how to do it. And this is one big benefit of the reactive way. Now that we have defined how the view model should be started, this base view model that inherits from the reactive object, let's get started with the usual properties. How are properties defined in reactive UI? Well, this is the mutable properties. The mutable properties are properties that the UI can directly change due to user interaction, usually with a two-way binding. And fear not, these are the classic properties with both getter and setter. So it will be almost the way you already defined the properties in the view models. It has a backing field here. You see the backing here, backing field, and in the getter we are just retrieving it. And the difference that you may notice is the set definition. It uses this helper method that takes the backing field, and this is a common way of invoking this change notification. And well, this is to be modified by the view. So in the views, you will likely have a binding to properties like this because they are thought to be modified by the view. And each time the property is modified, this change notification will be raised via the iNotify property change interface that is encapsulated. The usual mechanism is encapsulated in this call. So every time you invoke this, the name property will be signaled. And well, nothing much to explain because this is a plain and simple property. The only difference is the call raise and set if changed. And let's go ahead with the method that will be very useful for the definition of view models. This is the when any value. A bit of background. In C#, our sequences are represented by the iObservable interface, as I said in the introduction. Everything that is unobservable can be observed, by the way. And you just have to subscribe to it via the subscribe method. And that's the point of Reactive UI, to convert non-observable changes into observable sequences. Mutable properties are changed by the UI. As I said in the previous slide, these are the plain simple properties that we are so used to define in our view models. And we need some mechanism to handle these changes in a reactive fashion. We need to transform them into observable sequences. This is why we have the when any value method, this when any value method in this code. And what does it do? This utility method only requires a lambda expression to indicate the target property that you want to get an observable from. So if you indicate the property using the lambda expression, you will get an observable that reacts to the changes in this property. Then you can subscribe to it in order to use for any action or as the input for another observable, because composition is a key part in the reactive way. In this example, we have a name property that can be bound with a binding. Whenever the name changes, the name observable will receive the name and it will be pushed through the pipe, through the observable. The method when any value can be used to create an observable out of not only one, but many properties to produce a combined value, as we will see in the next example. Okay, this is a little more complex complex view model, and in this example, we are showing that we can create derived properties from other properties. For example, you see the full name that is derived from last name and first name. It usually is like that, so it's a classic example. The full name and is composed, and we have to derive from the first and the last name. Quite simple, right? And well, in this example, we are working with the mutable properties like this. Don't be scared by these compressed lines that are the very same in the previous slide. Is just the getter and the setter compressed in one line, and we are allowing the user to modify via a two-way binding the first name and the last name. Okay, since the full name is deriving from the first and the last name, how do we define this full name? Well, you can see it in the constructor, like it's usually defined. The full name is the invocation in this view model of the method when any value, and we provide not only one but two expressions. We are saying that this third value will be composed of the first name and the last name. So we are taking this value and this value, each element that will be pushed to the observable made from this property. And finally, in the last part, we are providing an lambda expression that takes both the first name and the last name, and we are specifying what we should do with them. We are creating, you see the dollar sign that creates a string with the first name and a space in the middle and the last name. And this call is projected to one property. So once we have made the observable we have created the observable with the when any value call, we are creating from this observable a property, and this property is specified in this syntax. We are saying that the parent of the property is this view model, and the source of the property we want to project this sequence to is the full name. So in the full name, we only have a way of getting the value. It doesn't have a setter nor a getter, but we are using this special syntax to say that the full name is the full name dot value. Why the value? Because the true property is creating this mechanism to propagate the change. It's like a helper that is called in Reactive UI observable as property helper, and it is of type string, and this is defined like this. The result of the true property is an observable as property helper. Excuse me, because it's very long. I need takes ages to pronounce, and I'm having troubles with this. But when you define the something with the to property, it generates this kind of abstraction. And in order to get the full name, you just have to get the value of it, and you are done. But it's just better to see it working. And this is a little sample video, a clip showing the thing working. Just see how it works. As you can see, whenever the first or last things change, the full name changes accordingly. And since we have defined them declaratively, there's no chance for it to fail. That's one of the top benefits you will get being reactive. And I have Visual Studio here open to show you how the code, the whole code is looking. This is uploaded to GitHub, so you can take the big picture and try anything I'll be showing. You have 5 samples that are very, very simple and are in the slides. But I have another example, the example number 6, that is a very complete application that you also have in GitHub. So this is the code I have shown you before, and I will run the application. And here we are. It's a big screen, so it looks not very good when it's maximized. Whenever we change the name Tony, Enrique, you change the name, and you can do whatever. Riona. You can put whatever, Smith. It changes accordingly. And this is very simple. You see that the code doesn't have a chance to fail because we are not subscribing to anything in this code. We are just projecting the first name and the last name, and we are specifying how the result will be handled. Let me drink some water. Speaking in English is very difficult for me. And well, we will go ahead with the next slide. The commands. This is another classic. Let's go with it. Commands are another common way to encapsulate logic that mutates the state of our applications. And you may have seen commands in other frameworks like Xamarin Forms, the Windows Universal Platform, or WPF, for example. They are usually bound to buttons and menus. These components, these UI components, are usually using these commands. And how does Reactive UI use commands? Let's meet the Reactive Command. The Reactive Command, remember this, you will be using it in almost every reactive UI application you will be doing. In reactive UI, commands are first-class citizens that are really similar to sequences. It's a particular implementation of the iCommand interface. You may have been familiar in the past with the relay command or delegate command, and everything that ends in command has a relation with the iCommand interface. But this one is tailored for reactive UI to fit with its approach. They look and act quite similar to other commands that you may have used. This delegate command, the relay command from MVVM Lite, a classic framework. But this reactive command has some superpowers. We will see in a minute. Each time a command is invoked, it will push the result of the execution through it. So you will be able to subscribe to it like we did with regular sequences. You see, this is the reactive command. Well, they are created using the static methods of the reactive command class, as you see. And a very common use is to create commands from tasks, like in this sample code. And there are many ways to create commands. You just have to use IntelliSense to discover the many ways. For example, you can use another observable, or you can use no other method at all. You can just create a reactive command and with no parameter, no anything. And the interesting thing about this reactive command, apart from being a particular sequence, because they act like sequences, it's because they handle all the logic behind the execution of the asynchronous operation. So while the operation is being executed, the button will become disabled automatically, and it won't become enabled again until the operation has been completed. So if you attach this do something command to a command in the interface, whenever you click it, you will be in front of an automatically grayed out button that becomes disabled whenever you click it while the operation is taking place. And in this case, we are interested in reacting to one click, or whenever the user has invoked a command via a button, via a menu, or whatever. And how do we subscribe to commands? This is because we really need to know when a command has finished its job, and to do so, to be notified when a command has finished its job, we can subscribe like if it were an observable sequence. In this example, we have defined a command that will perform a method, an async method, that is the do something async, this one. And the do something async command is just delay to emulate some kind of processing. Then in the next line, we are subscribing to the execution when the command finishes the execution, and after it's finished, we set the message property to the text finished. But well, it's better to see it in action, and this is what we'll be doing in this short clip. See, we are clicking the button, and whenever you click it, it says finished when the execution has finished. You noticed? So in order to see it, the real example, this is the example, this is the code, this is exactly the code that we are executing, and just replacing the number of the example. The new example will pop up eventually. Let's wait a bit for it to compile it. Okay, this is the real thing. Not tricky. I'm not cheating. You see? It's a very interesting thing, and at the same time, it is very simple and very basic. Let's head to another interesting thing that we can do with commands, and it is the projection from a command to a property. As I already mentioned, commands are very similar to sequences. You can even project them to properties, and in this sample, we are projecting the results of the load HTML method that is here, create from using the same method before. This is very common. We are loading the URL when the command is executed. And we are projecting this observable, because reactive commands are observable. We are projecting like a property, like they were an observable created with any value method. It's almost the same, and this time we don't need it because the reactive command is already an observable thing. And when we invoke the to property, like we did before with the full name, we are projecting the result of the load HTML method, and it's being projected to this property. Like I did before, it's best seen with a short clip. This is like a web browser, but instead of loading the website, it only loads the HTML. So in Visual Studio, it's the sample number 2, and let's see it in action, and we'll see the complete code. The code is, let me show you the code. This is not the sample 1, the sample 2, sorry. This is the sample 3. Okay, this is the view model, and as you see, they can load property, the can load observable is defined here. I haven't explained it before, that you can use an observable to define when a command can be executed. And in this sample, the can load observable is defined using the URL property. Whenever the URL is not null or empty, the command can be executed. This is another parameter that the create from task method accepts, and you can put the observable to indicate when the command can be executed, and in addition with the definition of how the command what the command will do. In this case, the command load HTML is creating an HTTP client and getting the string provided by the URL to load. And we are projecting the outcome, the result of the command, to a property that is called HTML. The HTML is bound to the text box that is, well, not it's a text block that is read-only. And sorry, this is the previous sample because I mistakenly put 2 instead of 3. This is the correct sample. If you put this http google.com, and you cannot press this because we have defined that we cannot click, we cannot invoke the command when the URL is empty, but we have already put something inside the text box. But the problem with this text box is that it has not updated yet, so you have to click over another part of the window in order to make this realize that this has changed. For example, if you delete everything and you click outside, this isn't available. You cannot load anything. But if you do put something, it will make you able to load the command. Whenever you have not put anything, it won't let you go. It won't let you invoke the load command. And this sample is very nice, and it's very useful to learn what the Reactive UI thing is all about. And another more complex thing we can do with the commands is project properties in order to invoke commands. So this is another approach. Whenever a property changes, you may want to invoke a command. This is done using this syntax, and it's quite the same thing we did before, but the difference is that we are using this method, invoke command, and this is the command that we want to invoke, the execute search command. And this is a funny and useful way to describe what reactive extensions pipeline does. We are creating a non so simple observable, we are creating this. When any value changes in the search query property, we will throttle the elements. That means that, well, this is an operator, and you have an extensive list of the operators of the reactive extensions library in the websites I mentioned before. And these are all operators. This is from Reactive UI, but these are from the Reactive UI, from the Reactive X library. And the invoke command is also from Reactive UI. But this throttle, select, and distinct until change, and these are there if you are using Reactive X. The throttle is an operator that will only get the last element of the sequence when no new elements are pushed for 0.8 seconds. So this is what this throttle operator will do. It will create a new observable using the last when any value observable. It's meant to be read in this way, starting from the top line. We are creating this observable, and this observable will be created from the previous one, and the select one will be created from the throttle one, and the distinct until changed will be done the same way. So we will apply the operators. Don't be afraid if you don't know what this distinct until change does. You just have to look over the material, the website I have provided before, and you will actually see what this is all about. But I will tell you how it's meant to be read. We will be creating an observable out of the search query property that will throttle the elements using this time span for 0.8 seconds. And we will only take the last element from this sequence whenever it has been pushed a lot of items. We only will get the last one, and we will select from the throttle element. We will select the element, but only the trim. We are converting the query, the item. We will trim it, and the trimmed element will be this observable will be the input of the distinct until change. Distinct until change will only emit elements that are different. If you push, if the sequence push, for example, 1, 2, 3, the resulting observable will emit the 1, 2, 3. But if the sequence emits 1, 1, 1, it will only emit one single element. It's a bit difficult to get into if you haven't learned something about Reactive X, the reactive programming library. And maybe if you are running the samples, you will get a better idea of how it works. And finally, when this observable has been created, the when any value throttle, where this apply that filter, this will filter out every element that is null or white space. And finally, at the very end of the pipeline, it will invoke this execute search command. And in the second line, you notice that we are using the subscribe method, and we are just only getting the results and establishing setting the search results property to the element that we received through the command. And finally, this is the clip to make you see a bit clear. And it's interesting that while you are writing, the search is not being triggered. It's only when you stop typing for more than 0.8 seconds when the search command is invoked. So this is interesting because it allows your users to type and correct their mistakes without launching the search command whenever a new letter is input. For example, you can type A, and the search won't be invoked until you have stopped typing. Well, in the video, in this clip, you cannot see because after typing the A's, I've stopped the video and it's not refreshed. But I have a cool example in this solution. That is the example number 4. That is exactly this one. It's just a little search window, and the window will not search until you are done searching. For example, webinar Reactive UI. You stop typing and the web search results are there. Whenever you change something, it will invoke the search and refresh the results. And if you do this and you start correcting whatever storms like a search, it won't launch the search, so you are not pushing so many searches to the server, because it may be even if you are using an external service, you may be you may have one rate limit. You may hit too many requests per second or wherever, and you may be charged because you are requesting a lot of searches to the client, to the web search client. And let's take a look to the code of the sample number 4. That is the number 5, because I started from 0, and this is the code. The code that is in the view model. It's only intended to be a sample, and we are creating the client, the web search client, using the API key and so on, and we are defining the search command from a task. The task is a search that is made here. You just invoke the method to actually do the search, and after you are done with the search, we are projecting the results to some object I have created for the sample. That is the search result that has the display URL, the title, and the description. And when this has finished, it will provide you with an enumerable of search results that will be used to create to do the search. And whenever the search command has been invoked, it will process the search, and the search results we are retrieved using this R argument. We are establishing, we are setting, that fits better, setting the results that we have obtained. It's pretty simple, and the most interesting part of this is this precisely. This is created using the Fluent API style, and you can run this and play with the sample and discover how it works. And lastly, I have prepared a demo that I've shown. It's more complete, and it's a nice example that uses Azure Cognitive Services to detect and identify faces. I used it in an event, and it was pretty successful. So I will show you the thing, and I hope you like it. And this is the thing. This application is done entirely using Reactive UI, and it's thought to have this kind of menu in which you can detect faces like this. This is a menu. It's not so evident, but you get the thing. You pick the images. For example, you are getting all these pictures from popular actors, widely known, and you press the detect command, and automatically you have seen the progress ring appeared while the command was acting, and now you have the faces of all the pictures. And well, we have another features like the group feature that you can group pictures by similarity. This is the list of the people that I want to group, and sorry, this is not the feature I'm talking about. The group feature is this one. I'll show you the identify feature, the next one, and this is the group feature. Yes, this finally is the group feature, and you see it's grouping pictures by similarity. Identify this. That's the same thing. You can identify the people in the pictures. Well, the important thing is that it's an example of what you can do using Reactive UI and the Reactive X way of thinking. And it's quite robust and fail-free. As you have seen, while the command has been doing its job, it automatically shown their progress ring on top, and identified lots of pictures this couldn't be identified, so they are not with the rectangle on the face, but you see. And this application is ready for you in GitHub. I will provide you with the links in the description of the video when it's uploaded to YouTube, because this video will be uploaded to YouTube. So fear not about missing the action. You are having the links for sure. And the webinar, the sample I have presented during the webinar RX solution is there for you to learn from it and to ask anything you can think of. You can ask me using the Twitter account or the email account, wherever, from this sample, from the face demo, or wherever. And finally, a big call for questions or doubts you may have. This is just intended to be an introduction. I tried not to bother you with complex code or whatever, but I'm sure you will find it very simple if you look at the code that it's uploaded to GitHub, and if you run the applications, you will see quite easier what I have presented to you. Okay, do you have any question? Okay. Okay, I have seen a question by Tony. Does it work with FODI, iProperty change, and auto iNotify property change? It absolutely should work. It should work as long as this is using internally the same iNotify property change interface. In fact, the reactive object we are deriving from is implementing this interface. And well, the cool reactive app clean code with 50 megabytes of memory. Yes. Okay, Tony, thank you. I'm more than pleased that you have appreciated this big effort I put to present you in English, since it's not my native language. And I think I will have, we have another question. Okay. Why we need to subscribe to a command in order to show the message finished? Okay, because whenever a new element is pushed, if you don't subscribe to it, the sequence just throws the item. If nobody is subscribed to the pipeline, the element is not doing anything. It's like you are putting the element into the trash, into the trash can. We need to subscribe in one way or another. Otherwise, we won't have we don't have any clue of what has been put into the sequence. Okay, it's I'm reading the question. It's not enough just showing that message at the end of the method linked to the command. Well, yes, you can do it like that, I just put that for the sake of completion in the sample. But if you want to log any message whenever the task has finished, you can do it. You can just put a message, or you can set the message property inside the very same method. But the reactive way of thinking has taught me that it's preferable to have one thing at a time and to convert one item at a time, or to process one item at a time. Since this pipeline can be as complex as you want, you can do whatever composition you want, and sometimes it's good to keep it the changes keep the changes outside, so you don't have any undesirable let me find the word, consequences, yes, more or less that's the word, where you are mutating things inside a method that is supposed to retrieve things. You are creating a consequence. You are mutating things. If you are saying that a command is getting something, it's better to just get something and stay simple. You are just reading something. If you are mixing things, you are mixing reads with writes, it can become complex to maintain. Okay. It seems okay, Marcos. Yes. If you go to the sample, and I'm not sure if I can put the. I will try. I will try to copy the GitHub URLs. For example, GitHub, my profile. Okay, let me check. The RX webinar URL is here. And let me check. Maybe it's better if I put this inside the chat. Okay, this is the webinar URL, and this is the Face API demo, the demo. It's the Face API demo. That is okay. Perfect. I think you already have the links. This is the other link. I hope you have it. You can write it down and check it, and you can use let's check. You can use the issues part of the project to ask any question you may want to know, and I will answer as soon as possible. Okay. If you don't have any question, we can take this as finished, this webinar. Okay, no new questions. So, thank you very much for attending to this webinar. And if you are kind enough, please use Twitter or wherever to give some feedback of this webinar. I hope you can forgive my accent and my mistakes. I'm trying hard in order to improve my English level. And let's meet in another webinar. The next webinar is the first webinar, I'm not sure which one is. It's the webinar. Let me check. Maybe it's of your interest. This, okay, I didn't remember. It's the mixed reality with HoloLens, and you may subscribe to it using this URL in brintia.com/blog. As I said, thank you, and let's meet in another webinar. Goodbye, everyone. See you.